Welcome to our last chemistry module. This is module number 19, and we're going to spend just a very short time just going over the types of chemical reactions that there are. We're going to identify the 5 main types of chemical reactions. Synthesis and decomposition are opposites of each other. Single and double displacement are very similar. It just depends on whether you're dealing with an element or a compound in the reactant side of the equation. And then the very last one is about combustion reactions. Okay, we're not going to spend too much time going into all of the lab activities, obviously, or the details of more different types of reactions, which we would normally have done just based on time. But recognize the fact that we would have spent time talking about acids and bases and would have done neutralization reactions as well. Okay, all right, so I'm just going to go through the solution set very quickly with you because for this module, I'd like you to watch Tyler DeWitt's videos first, and they explain everything in a nice, succinct way. And so I'm just going to highlight that for you and make a little summary note as best you can. Okay. First type of chemical reaction is called a synthesis reaction. You recognize that by having more than one reactant and only one product. So A plus B gives me AB, if you will. That's the the summary of what that type of reaction would look like. How do you recognize it? Again, you've got one compound in the end. Remember, a compound is a molecule or a particle, and only one of those, that's a synthesis reaction. The opposite of that is a decomposition reaction. So if you start with one reactant, which you would if you had AB giving you A plus B, you start with a complex reactant, only one, and you break it up into 2 or more. So it's a very sad split, right? The third type of chemical reaction is a single displacement reaction. You recognize this by having an element and a compound, and then you end up with a compound and an element. So the one element is going to kick out one of the other elements in that chemical reaction. How do you know which element gets kicked out? You want to recognize that metals react very similarly, and then nonmetals react similarly. So in this example, if I have zinc and hydrogen chloride, I know that the zinc is going to kick out, the zinc is going to kick out the hydrogen because in this compound, hydrogen chloride, the hydrogen is actually acting like the metal because it comes first in the name. So I know that it's going to be zinc chloride and hydrogen gas and not zinc zinc hydrogenide. It's not going to be that one because the zinc is going to kick out the one that's like it in a chemical equation. Okay, so that's where I've written in some of the extra stuff here. How do you know which one gets replaced? The metal and the non-metal. If I've got a non-metal, it kicks out the non-metal. If I've got a metal, it would kick out the metal. Okay, lastly, we've got a double displacement reaction, and just like the name, you can recognize this type of chemical reaction because you have compounds. You've got 2 compounds, and again, the diagram's a little hard to tell because I wanted you to add some highlights to this so you could see which one gets kicked out or replaced. And in this case, this one would kick out this one, and so the partners break apart, switch, and you get 2 new products. The very last type of chemical reaction that we deal with is combustion, okay? And for a combustion reaction, you're looking at a complete reaction reacting with oxygen. That's what you're thinking when you see combustion. Okay, any of the hydrocarbons are all fuels, and so there's a little trick here for remembering some of the different hydrocarbons. We did a little bit of this in nomenclature. We looked at methane, but any hydrocarbon that's got any molecule that's got more than one carbon attached, there are particular names for those, okay? So that's something we can leave until grade 11. If you remember that there are 2 products when you have a complete combustion of hydrogen, and the 2 products are carbon dioxide and water, you're good to go. If enough oxygen is present, then you end up with a very clean reaction, a very clean combustion reaction. If the number of oxygen atoms is limited, okay, then you can get what we call an incomplete combustion of a hydrocarbon. And in this case, you have 4 products. You've got the carbon dioxide and water that you had to begin with, but you've also got carbon, which would be this one here would a solid carbon, that would be like the black soot that you get when you burn a candle. You can see that carbon. And then the other product that you get, because there are 4 of them with incomplete combustion, you get carbon monoxide. And this is the molecule that's very dangerous that can attach to hemoglobin in your bloodstream, in your blood, and prevent oxygen from getting to your cells, okay? So if you're in a situation, this is where, you never ever want to take your barbecue and put it inside your house and barbecue, because you end up with incomplete combustion and you can die from carbon monoxide poisoning, okay? So those are the ones you want to watch out for. And again, you can practice doing your balancing of your chemical equations. Okay, so that's it. We've got synthesis, decomposition, single or double displacement reactions, combustion reaction, and of that you could have a complete or incomplete combustion reaction, and that's all we have time for grade 10 chemistry this year. Don't forget to now go back to the balancing equation sheet, because now you can identify these reactions based on the type of reaction, and that was this column right here. So give those practice and check your solutions, and then I think you've done a great job on working through all of your chemistry. So congratulations on that if you're still sticking with me. I'm going to do some biology next week, but we're going to not biology, we're going to get into the climate change unit, and I'm just going to do a couple little modules on that. All right, so let me know how it goes, and there's lots of online practicing you can do if you want to do a bit more work on balancing chemical equations. Okay, take care.